Hello everyone, this is Ilavarasi, Assistant Professor, Department of EEE, Karpagam Academy of Higher Education. So today we are in the 8th module. Hope you all remember our past 7 modules which we have started with the basics of electricity. In that we have come across the definition for current, voltage, power, and also we have discussed on the basic symbols that has been used in the electrical circuit and about the Ohm's law in your second module. And in the third module we have come across the factors on which the resistance of the conductor depends, and in that we come across resistivity, length of the conductor, and also about the area of the conductor. And in the fourth module we have discussed on resistors in series, how to calculate when the resistors are connected in series. And in the fifth module we come across resistors in parallel. In that we have solved few problems on how to solve a parallel circuit. In the sixth module we have discussed on the heating effects of the conductor, and in that we have discussed on the daily appliances like in electric iron kettle, how the electricity flows. And in the last module we have discussed about the electric power. And in today's module we are going to discuss on the problems how to calculate the electrical parameters in a circuit. So few formulas we need to remember. By Ohm's law, how to calculate my voltage? It is given by V is equal to I into R, and I can be calculated by substituting V by R, which we have derived from a small triangle. To simply remember, V is equal to I into R and I is equal to V by R, whereas your R will be given by V divided by I. And this is ohms, this is ampere, and this one is volts. So these are the basic formulas we have used by Ohm's law. And power can be calculated as V into I, which can be rewritten as I square R from substituting from your Ohm's law, and also power can be written as V square by R. This will be given in watts, and this is also in watts. The unit is watts. So these are the basic formulas to calculate electric parameters. And also we know that the R series circuit, that is total resistance, can be calculated by R1 plus R2 plus R3. Whereas in case of my parallel circuit, if suppose two resistors are connected in parallel, the parallel circuit can be given by R1 into R2 divided by R1 plus R2. And by Kirchhoff's voltage law, we know that my total voltage rise will be equal to voltage drop, V1 plus V2 plus V3. And by Kirchhoff's law, the total current can be given as I will be equal to I1 plus I2 plus I3. So based on all these things, we are going to solve a problem. And the first problem is like 3 resistors that has been connected in series. Given ohms of 2 ohms, 3 ohms and 5 ohms. And that has been connected across here. A 20 volt supply. This is your voltage. We are supposed to calculate the current, voltage drop across each resistor, and the power. So from the problem it is clear that we have 3 resistances. R1 is 2 ohms, R2 is 3 ohms, and R3 is 5 ohms, which is connected to a voltage supply of 20 volts. And the solution is, we know that V is equal to I into R. So the total resistance From this problem, we can able to know that the 3 resistors are connected in series in the sense my R total will be equal to 2 ohms, 3 ohms, 5 ohms. So 2 plus 3 plus 5, which is nothing but 10 ohms. The total resistance RT will be equal to 10 ohms. This is given from this formula, series resistance. So what happens? My R is 10 ohms. My voltage is 20 volts. So current can be easily calculated as I is equal to V divided by R, which is nothing but 20 by 10. So my current will be equal to 2 amps. So finally I have calculated the value of current. Now the next step is I need to calculate the power in the circuit. Power in the circuit is given by power will be equal to V into I. So my voltage is 20, whereas my current is 2 amps. So power will be equal to 40 watts. I can also be able to calculate my power dissipated in each resistor. Like I know that power will be equal to I square into R, right? So in case of my first resistance R1, the power will be equal to I square in the sense it is 2 square and R1 resistance is nothing but 2 ohms. So 4 into 2, this is 8 watts. And in case of my resistor 2, the power dissipated across resistor 2 is nothing but 2 square into 3. So this will be 4. So we have 12 watts. And in resistor 3, the power dissipated will be I square R, so 5. So the value is 4 into 5, 20 watts. So even now if you calculate the total power, P is equal to P1 plus P2 plus P3, the total power dissipated across each resistor, you will get 8 plus 12 plus 20, which is nothing but 40. That is what the power we have received while using the formula V into I. The total power is equal to the power dissipated across each resistors. So this is how you need to calculate a problem when 3 resistors are connected in series. And the next one is we are going to solve a problem when 4 resistors are connected in parallel. Now we have got a clear idea on how to solve the series circuit problems. This is about problems on parallel circuits. So I am having 4 resistors that has been connected in parallel. And this is connected to a voltage supply. We all know that in case of your parallel circuit, the voltage will remain constant, whereas the current that is passing through each branch will be different. And the current that is passing through each branch is given as I1 is equal to 0.6 amps and I2 is equal to 0.3 and I3 is equal to 0.2 amps. I4 is equal to 0.1 amps. We are supposed to calculate the individual resistances R1, R2, R3 and R4. So we know that I will be equal to I1 plus I2 plus I3 plus I4. So what happens? The total current I will be equal to 0.6 plus 0.3 plus 0.2 plus 0.1. So my I will be equal to 1.2 amps. R is equal to V by I as well as V is equal to I into R in case of your Ohm's law. So the total resistance that has been given in the problem is 20 ohms. So we are going to substitute in this formula to calculate the voltage, which is nothing but I into R, and I have calculated the I as 1.2 and my resistance is 20. So your voltage will be equal to 24 volts. So from the given problem, I have calculated the total current and also the voltage value has been calculated. Now we are going to calculate the individual resistances. Because the cumulative resistance has been given, we need to calculate the individual resistance. So R1 will be equal to, in case of parallel circuit, as I told you, the voltage will remain same. So your current value will get changed. So voltage is 24 volts. In case of your current, I1 current will be equal to 0.6. So the next one is R2. R2 will be equal to V divided by I2. So your voltage will remain constant, current is 0.3. In case of R3, voltage will remain constant, I3, and this will be given as 24 by 0.2. And your R4 is constant voltage by I4 current, that is nothing but 24 by 0.1. So we can easily calculate as 240 ohms, 120 ohms, and 240 by 0.3 is 80 ohms. This is 40 ohms. So individual resistance is also calculated in this problem. This is how we need to solve a parallel circuit. So this is what we have covered in the entire module. In the first module, we have come across the basis of electricity, in which we have discussed that current is nothing but the rate of flow of charges, and the potential difference is nothing but the work done in moving a unit positive charge from one point to another, and power is the rate of transfer of electrical energy in a circuit. And we have also discussed that these are the particular symbols that has been used in an electrical circuit. An electrical circuit is nothing but the interconnection of your electrical components through which your electric current flows, and network is nothing but when you remove the electrical source or voltage source, that particular component it is there, we call it as networks. And in the next thing we discussed on the Ohm's law, which is nothing but the voltage is directly proportional to the current provided your temperature remains constant. And in the third module, we have come across the factors on which the resistance of the conductor depends, and in that we have discussed that the resistance depends on the resistivity, length and area of the conductor, and we have solved few problems on this. And in the fourth module, we have come across the topic of resistance in series, and we know that when the resistors are connected in series, it should be added. So our total or our series resistance will be calculated as R1 plus R2. And in case of module 5, resistors in parallel, we have to solve that when the resistors are connected in parallel, the total resistance or equivalent resistance will be given as R1 into R2 divided by R1 plus R2. And in the sixth part, we have come across the heating effects of current and how this electric current is used in day-to-day life in all the electrical appliances like your electric kettle, electric iron, everything we have discussed on this part. And in this module, we have discussed about the electric power, which is nothing but the rate of transfer of electrical energy in the circuit, and power is nothing but voltage into current in case of your DC circuits. This can also be written as I square into R, that is current square into R, and power will be given as V square by R. In different problems we have solved on this electric power. And finally, in today's 8th module, we have solved problems on how to calculate all these electrical parameters like resistance. If you have given in a series circuit, how to calculate the voltage drop in a circuit, and in case of your parallel circuit, how to calculate the individual resistances as well as the current in the circuit. These all parameter calculation has been done in the 8th module, and hope I have given a deep insight on the basics of electricity, and this will be very useful for you. And with a great innovative topic in the next session, we'll meet. Thank you.